Welcome to another video session on Math 302 based on the topic linear mapping. That is the main topic we want to consider for today's class, linear mapping. Now, for this topic here, we want to consider a linear mapping, phi such that we actually have this linear mapping from a three-dimensional vector space to a two-dimensional vector space F. Okay, so if we actually let this phi be a linear mapping from this to this, and actually it is the linear mapping is given by this expression here, which simply implies that the linear mapping phi of x, y, z is equals to x plus y plus z and y plus z. Do you know that I can actually present this in a matrix form, whereby this linear mapping x, y, z, which is equals to this expression, can be expressed in matrix form such that we have this first result here, this x plus y plus z. You write it up here, x plus y plus z, and this y plus z, you have to write it down here. Okay, if you have any other one again, this is in a row, you can write it in a vector form, that is in column form, right? In a column matrix. So then the only thing I just need is, if I want to write this in a matrix form, I only need the coefficient, whereby the coefficient of x here is 1, the coefficient of y here is 0, the coefficient of z here is 0. Okay, let me write that clearly. 1, 0, the coefficient of z is 0. So in this case, I notice that x is missing. Is there any coefficient for x? No. That means I have my coefficient of x. Sorry, what am I even saying? The coefficient of x here is 1, the coefficient of y is 1, and the coefficient of z is 1. Take note, 1, 1, right? But here in this case, x is missing. That means the coefficient of x in this case here is what? Is 0. While the coefficient of y here is 1, and the coefficient of z here is what? Is 1. So this ends. Okay, I think this is just what I need. This thing here is actually the matrix for A, the matrix transformation of A from phi. But I'll still come back to this. Okay. Now, we have this linear mapping that is being defined by x plus y plus z and y plus z. So what do we want to do with this? We want to find two things. In fact, we want to find three things. Okay, 1, 2, and 3. So let's start with the first part. The first question says, find the matrix A. Find the matrix A of the linear map given to us with respect to, that means when I say with respect to, you know what that means? We need to consider, what are we considering? We are considering the standard basis. Now, if you're asking yourself what is standard basis, if you don't know that, I will make sure I explain that clearly to you. We need to find matrix A of that linear map given to us with respect to standard basis of this um, field. That is a three-dimensional vector space, from a three-dimensional vector space to a two-dimensional vector space. That's the first question. And let me just tell you that I've gotten the answer for this matrix A. The final answer for this matrix A is what I have here. But if you do it this way, you will not get your full mark, because this is just the short method to derive this matrix. Because I did not even, the condition is they asked me to find that matrix with respect to standard basis, and I did not even present any standard basis here at all. This is just like a short method. You can try to, after showing the full solution with respect to standard basis, and then you actually arrive at a final answer, you can as well relate it with this one, compare, so that you can, this one is always correct. Okay, there is no mistake in this. So you can actually make mistake while trying to show it with respect to standard basis. So if you are able to show it with respect to standard basis, and you arrive at a final answer, make sure you always compare with this short method, so that you can actually be sure if you are correct or not. So to find the matrix A of this linear map with respect to standard basis of this three-dimensional vector space to two-dimensional vector space, this is just like a 3 by 3 matrix. This is a 2 by 2 matrix. Okay, if you have F2 to F3, that means you are trying to deal with a 2 by 2 matrix against 3 by 3 matrix. Please take note of that condition. So you need to verify this clearly to be sure whether you are doing 2 by 2 matrix against 3 by 3 matrix. So it will be stated. It will be stated in the question. I think this is for the first question, and I will give you the main explanation to it. And that reminds me, I was actually asking you. You might be wondering what is standard basis. A standard basis is just as if you have, let's say we have okay, what is the standard basis of F3? What is the standard basis of F2? Let me put it that way. The standard basis of F3 is actually the identity matrix of a 3 by 3 matrix. It's an identity matrix of 3 by 3 dimensional space. Okay. What is standard basis of F2? Is actually um, an identity matrix of a 2 by 2 dimensional vector space. Whereby, in this case now, a standard basis of F3 now will be of this format. If you want to write an identity matrix of 3 by 3, you have to write one in a diagonal form, 1 1 1, from left to right diagonal. Then you fill the remaining spaces with what? With 0. So the standard basis of F3, you are using this. Make sure you use this. Is that clear? And F2, the standard basis of F2 is just a 2 by 2 matrix. That is, the left to right diagonal just put 1 1, making 2. Then you fill the remaining space with 0. So this is what you are considering. You are trying to find the matrix of that linear map with respect to this F3, this one against this one, from this to F2. So don't worry, I will make sure I explain that clearly. As time goes on, you get to understand it very well. Okay, but just take notes. That is what dimension. That's what we have as standard base. Standard basis. Um, let's say we have another. Let's say we have another. Let's say we want to find another matrix. So the second question says find another matrix. So that another matrix, I don't want to call it B. So I want to call it A prime. Find another matrix A. Okay, and we want to look for another transformation matrix. We want to look for another matrix A. So I don't want to use A. Now in this case, I'm using A prime, just another matrix entirely. In some other question, you see find matrix C or find matrix D. Okay, such that find matrix A prime, which is find another matrix A of that same phi. But in this case now, we are not looking for that other matrix with respect to standard basis. Now they now want to give us, they said we should not use the standard one. For the second question, we now want to find another matrix with respect to a given basis, not a standard one. And the given basis now, with respect to the basis, okay. Now let me state it. The given can't I scroll up? What's wrong? Wow. Okay, just next page. All right, this page by page. So we want to consider another matrix of 5 with respect to the basis. Okay, the given basis, let's start with the first one now. Instead of, this is F3 to F2. Now in this case now, the one for F3, the one for give the basis for F3 now is given to us as, we always use B prime to represent that. Please take note. B prime. A given basis, we always use B prime. Okay. Now if I want to give a basis of F3, so the given basis of F3 here is given to us as -1, 0, 2. That's not all. We also have another one again. That is, if you have F3, that means you must have 1, 2, and 3. Let's check another one again. We have 0, 1, 1. We have this given to us as 3 -1, then 0. So this is the given basis, and that's not all. So the other one, we are for this part now, you should know that, okay, if I'm considering F3 and F2, okay, based on the major definition of the linear map given to us. So that means the second one, if you are using B prime here, the second one, please always use it. Will be stated. Well, let's use this one as E prime. And if it is not denoted in the question, you have to use B prime for a three-dimensional space, and or for the first basis that is being given to you, represent it as B prime, and the second basis given to you represent it as E prime. Please, there's a reason for that. Because that is based on what I think there's a proposition, and that is how it is being stated there. So for the E prime, we were given um I think for the E prime is actually given like this. We have it as minus 1 comma 1. Then the second one is 1 comma 0. I think that's all. So find another matrix A prime of 5 with respect to the basis. In this case, we are not using standard basis. We are now using a particular given basis. So how will you do these questions like this? So I think that's not all. They said standard basis of F3 and F2. So this one is a basis, this one and this one of what? Of the same F3 maps to what? F2 respectively. Please follow it respectively. This is the basis of F3. Why this one is the basis of F2? For F3, you'll be given three different results here, and for the second one, you have F2. That will be two different results here. So now this is what we have. Then for the last question, I don't know where I can actually put that. Okay, there's not enough space. I have to go on next. So let's deal with this one first. Then we'll now go ahead and solve the third one. So how do we find matrix A with respect to standard basis? How do we find matrix A with respect to the standard basis of F3 from F3 to F2? Now, a standard basis, like I said, let me divide this, but for a standard basis now, you always have the standard basis of F3. I said represent it as, okay, a standard basis of F3 is actually equals to this 111000000, right? Is a 3 by 3 identity matrix, right? Such that, please take note, the first row here is always our small letter E1. E is an identity. Is either I represent an identity as I, or in algebra, sometimes we represent it as E. Digital logic. So, whereby this first row represents small letter E1, this second row represents small letter E2, and this row represents E. That means E1 is 100, E2 is 010, and E3 is 001. So automatically speaking, since this represents a matrix, I can call this one to be capital letter E. So this capital letter E now is our standard basis of any vector spaces, whether 3 by 3, whether F3 or F2, okay, based on how you want to give the result. The standard basis of F3 now is represented. I'm using capital letter E since I have it as small letter E1 here. I'm using E2 here. I'm using E3 here. Okay, so we use capital letter E. For a standard basis, we use capital letter E, but for a given basis, is either we use E prime. For a given, we use E prime. So for other one, if you have more than one given basis, the other one is B prime. So that's just the logic. So that means in this case now, E can just be equals to, you can write this one as E1 comma E2 comma E3, which is also equivalent to this one. Now is, I'll use this curly bracket here, then this E1 will represent, this is how it's meant to be. Okay, this E1 will now represent 1 comma 0 comma 0 in a bracket. This E2 will now be 0 comma 1 comma 0, and this E3 will be what? 0 comma 0 comma 1 in that case. But I just want you to understand what standard basis is of F3. So now let's come back to this. We want to look for matrix A with respect to the standard basis given to us. So how are you going to go about that? Okay, to look for matrix A based on this definition, linear map definition given to us of X, Y, Z. This is the first step. Write out the linear map definition that has been given to you. We have it as X plus Y plus Z. That's the first one, comma. Then the second one is Y plus Z. I noticed that this thing actually looks exactly like saying I have F3, I have three values, three expression here, F3 against 1, 2, F2. Okay, so now if I now want to make use of with respect to, don't forget, with respect to the standard basis, right? That means in this case, what will I use? This is X, Y, Z. So I have three different digits, right? With respect to standard basis, the standard basis I have the standard basis of F3 and the standard basis of F2. The standard basis of F3 now, let it represent this particular E. Okay, let it represent this E prime. Okay, I think the other basis now, I can use it as B prime. The other standard basis will now be B prime, such that that one in that case, sorry, that will be B. The standard basis, that will be B. The standard basis for F3 is E. The standard basis for F2, let's say it is B. Okay, so such that in that case, I will now have just 2 by 2. Since it's F2, right? I will have 2 by 2. That's just a 2 by 2 matrix. 1, 1, 0, 0. And this represents E1. This represents, sorry, I can't use E again. I'll use F1 here. The next letter after E is F. And I'll use F2 here. So that means F1 represents 1, 0. F2 represents 0, 1. So that means my second standard base is just of this format: 1, comma 0, then 0, comma 1. So that's all. So now let's come back to this again. I have X, Y, Z, right? This show an image of F3, though this shows an image of F2, right? So now, if I now want to consider this X, Y, Z now, which one will I consider? Which standard base, with respect to a particular standard base, which one will I consider on this left hand side? Is it the standard basis of F2 or the standard basis of F3? So you should know what that will be. For this part, you should know that you are relating it with respect to the standard basis of F3. So F3 will appear here. So that means in this case now, for F3, what are the standard bases? Look at this. The standard basis of F3 now is E1, E2, E3. So in this case, you are expected to insert E1 here. You come down again, you insert standard base of E2, and then the third one, you insert the standard base of E3. Please take note. This will now be equal to, this is just like a general format of how it looks like. So therefore, you are expected to write, okay, you are expected to put something in a bracket here, such that in this bracket here, you already have E1. That's for the standard basis of, this represents standard basis of F3. Now, whatever you put here now represents the standard basis of F2, and standard basis of F2. So I'm using small letter F1. So this is, I'm using F1 in this case all true, and I'm using F2 in this case all true. Such that we always use X here. If I use X here of F1, what will I use in this case? Y. I think that's all. Since I only have an image of F3 against F2. Against F2 now I only have X and Y. Please take note of this rule. So that's how it actually works. Okay. So then, I'll also see for this one, I have to repeat everything. That's it. Please just understand this pattern. If you don't understand this pattern, you will not be able to get the correct answer. Please. Let me just say this is just like a general formula that you must follow. Okay, let's just put it that way. Let's just put it that way. If you want to look for matrix A and you are considering with respect to standard basis, with standard basis, make sure you check how many expressions do you have? Three. So which one are you considering? Standard basis of F3. And standard basis of F3 represents E1, E2, E3. So write E1, E2, E3 respectively. But in this case here, look at the question given to you, the expression given to you, okay, is of two different expression. So that means I'm considering is an image of F2. So I want to look for standard basis of F2. And standard basis of F2, you always use, is always a 2 by 2 matrix, whereby the first row is F1. Since I use F1 because the next letter after this E is F. Okay, it's not actually based on because I have F2 here. No, that's not the reason. It's actually based on the fact that I use E1 as an identity here, E2, E3. So the second standard basis of F2, I will now use F1, F2. Since it's a 2 by 2, and it being is F3 against F3, that means I will still have a 3 by 3 matrix here again, such that the first row will be F1, the second row will be F2, and the third row will be F3. So I will come here and write F1, F2. I will still have F3, but it will be constant throughout in the colon. Okay, so now if I use X again here and I use Y, that's just a general formula. Everything here is being repeated. So if I use X, 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 you see there is no, it's not unique. So I have to put X1 here, Y1. This one is X2, Y2. This one is X3, Y. Since they can't be equal or true. So that I will just make sure I have a unique. So whatever you get here, So you know how to form matrix A. So after you need to solve your own main target is we surely if from the question we already know our E1, we know our E2, we know our E3 from the standard basis. We know F1, F2, F1, F2, F1, F2. But what we need now is to look for X1, Y1. These are the things that we need. Look for X1, Y1, X2, Y2, X3, Y3. So if you can actually get all these values, let's say this one is 1, let's say this one is 2, you get this one at 3, you get this one as 4, you get this one at 6. So your A transpose is actually equivalent to how you see it. This is x1, x2, x3, y1, y2, y3. This will always be your A transpose according to the way you have it like this. So if you now want to look for matrix A will now be equivalent to when you take the transpose of A transpose. No, the transpose of A transpose is equals to matrix A. Take note. That is, you have to transform this one again. Vertical becomes horizontal. That means my A now will now be equals to this vertical result becomes x1, x2, x3, y1, y2, y3. So that's how it works in that case. So that means if I have 1, 2, 3, 4, 5, 6 here, my matrix A that I'm looking for will now be 1, 3, 4. Sorry, I'll be 1, 3, 5 rather. Then this one, it will be 1, 3, 5 here. Then this one is 2. This one will be 2, 4, 6. So that's just how it works. But don't worry, by the time you start inserting all these expressions, all these values, you understand it clearly. So please take note of this general template. Okay? Take note of it. That's what I want to use for the next one now. So recall that the template says I have phi of x, y, z. This is what we have. We have it as x plus y plus z for the first part, and the second one is y plus z, right? So we want to follow this pattern. Phi of the linear map phi of E1. What's my E1? So I don't know where I can actually put that if there's still enough space. Let me manage this place as my workings. My E1 is equals to what? 1, 0, 0, right? My E2 is 0, 1, 0. You can go and check. I hope you believe you know how I got this. 0, 0, 1. This is gotten from the identity matrix E is equals to E1, E2, E3. Whereby E is equals to an identity matrix of 3 by 3 matrix 1, 1, 1, 0, 0, 0, 0, 0, 0. So I'm still explaining it again. So this is my E1. Can you see that? The second row is my E2, correct? This third row is my E3. So I'll substitute here. You know, the formula here was E1, right? So that means it's equals to phi of what's my E1? 1, 0, 0. Right, done. Second one is what? What's my E2? My E2 now is 0, 1, 0. So my E3 now is, why are we doing this? Because we are actually trying to find matrix A with respect to the standard basis. Standard basis, take note. So this one is 0, 0, 1. So what will this give us? When you relate it, this is a map. This is a map now. It's a linear mapping. So that means you actually map this x to 1. X represents 1, y is 0, z is 0. So what will you get in that case? This is the definition here. If x is 1, y is 0, z is 0, substitute in this first result here, what will you get? This one now will give us, okay, let me just back it. I want to explain it clearly. I have a curly bracket, right? So that you don't get confused. Okay, now x plus y plus z, where x is 1, y is 0. I'm still on this first one. Oh. X is 1, y is 0, z is 0. So substitute it here, that will be 1 plus 0 plus 0. And that is what? 1 in a bracket, comma. This is y plus z. Y plus z is 0 plus 0. Y is 0, z is 0. So if I add it, that is what? 0 for the second part. So you put this in a bracket. So let's do the same thing for this one too. X is 0, y is 1, z is 0. Add it, substitute it here, that's 0 plus 1 plus 0. That is 1, comma. So this one, y is 0, z is 0, x is 0. So that's 1 plus 0. Since y is 1, z is 0, that is 1 also as well. So I have 1 comma 1 in that case. And for the last part, x is 0, y is 0, z is 1. 0, 0, 1. 0 plus 0 plus 1, that is 1. And then y plus 0, that's 0 plus 1. What am I even doing, self? Did I add this one well? Okay, yes. This is 1. What of this one? Y plus 0, that's 0 plus 1. I have it as 1. So this is what I have. Please follow this. You see the way I'm doing it step by step. So remember that this phi of E1 is equals to this expression that I told you about. I said we have our F1, We have our F1, right? We have our F1 here, we have our F2 here, parallel like that. Then we have X1, X2, Y1, sorry, X1, Y1, X2, Y2, and see it here, X1, Y1, X2, Y2, then X3, Y3. Do you understand that logic? So that's how it works. So that's what I want to do here now. First, I'll write my X1, okay? Then I'll open, then I will have to, let me check it again. X1, I'll have to open a bracket, okay? I will have to open a bracket here now. So I'm thinking of opening, okay? Let's say I decide to open a bracket now. I have my F1. What's my F1? F1 is the other standard basis, right? It's actually where I have my B, the second one, which is F2, an image of F2, which is a 2 by 2 identity matrix. So this first one here is my F1. This first row here is my F1. And my F2, 1 comma 0. And my F2 is what? 0 comma 1. So my F1 now is 1 comma 0. Don't ask me how I got that from what I have here. F1, G stand. Now I need F2. F1 is constant throughout the colon. So I will have my Y1 here too as well, of what? 0 comma 1 in that case. So let's continue. So this one is now X2. Repeat it again. 1 0 plus Y2 0 1. And this one is X3 still 1 0, Y3 still 0 1. So what are you going to do for me? This is what we want to do now. We want to look for X1, Y1. So now let's deal with this first row first. Let's do this first row. So to evaluate this first row now, the first result, to look for X1 and Y1, you can actually do it this way. See the pattern. Use this X1 to multiply this first result. Use this Y1 to multiply this first result. Add them together and equate it to this first result. First, first, first. Now let's try. X1 times 1, X1. Then plus Y1 times 0, 0 equals to this first result, 1. Automatically speaking, my X1 will now be equals to what? 1. Do you understand that? So my X1 is equals to 1. So I've gotten this result. Okay, now let's try. It was the first that we used. Now let's try the second one. Use this to multiply the second one. Use this to multiply the second one and equate it to the second one, right? So what would that give us? X1 times 0, 0. Okay, then plus Y1 times 1, Y1 equals this second result, 0. Automatically speaking, my Y1 now is equals to what? 0. So I've gotten this result here, X1, and I've gotten my result for what? Y1. That aside, done. Now let's come to the second part. Same thing, X2 times the first one, first one, first one. So looking at this now, I have X2 times 1, X2, then plus Y2 times 0, that's plus 0, equals to this first result, 1. My X2 still remain as 1 here. Now let's try the second one. X2 times this second digit, that is still 0, then plus Y2 times 1, that is Y2, equals to this second result, 1. So my Y2 is equals to 1. That aside. Next, X3 times 1 is X3, abi, plus Y3 times 0, I think that is, yes, that is 0, then equals to this first digit. So my X3 is equals to 1. So what of this? The second part, X3 times 0 is 0, Y3 times 1 is Y3, then equals to this second digit 1. So my Y3 is equals to what? 1 in that case. So I already have all my results now. Please take note. So like I said, my A transpose, now I'm looking for matrix A, but it's actually A transpose that will give us how we have it here as X1, as X2, as X3, according to the way we have it here. Okay, my A transpose is actually the way we have it here. And my A transpose now will be equals to, what's my X1? 1. My X2 is 1. My X3 is 1. This one is 0. This one is 1. And this one is 1 in that case. Right? So when we have something of this nature, so the next thing for us to do now is to now find A, and my A is actually equal, since A transpose is this, how will you find A? When you take the transpose of A transpose, this A transpose, when you now take the transpose of it again, then you get A back. So what would that give us? To take the transpose of this A transpose, now that means all this vertical, all this column becomes our row. Then the second column become our second row. So this is the matrix A that we are looking for. These are final answer. Very easy. Okay. You might not really understand this thing clearly until I try another example similar that will be that I will have to use this step to get that same example, to get the answer to that example. So this is how it works. Now let me recall you that. Okay, let me recall back. This is what our A is. So why do we have to go through all this stress when we have a short method for it? Because look at this, I have one, triple one, zero, and double one. So let's check. I've done that before, a very short method for that. Triple one, zero, and double one. You see, it is faster. This is very, very fast. Just look at the question. You have x plus y plus z. Write it, just turn this row to vertical, to a vector matrix. Then all you just need is just the coefficient. X appears, what's the coefficient? 1. Y appears 1. Z appears 1. This one, no x, that's 0. There is y, what's the coefficient? 1. What's the coefficient of this one? I think this one is 2z now. I will have y plus 2z. This one will now be 1. At this z, the coefficient is 2. So you see, it is faster this way, but you will not get your full mark because they already asked you to show that find the matrix of A with respect to standard basis. So you need to use this method. But to be on a safe side, I would advise you to use this method and then try the short method too, and then compare whether the answer is equal to this. Because if you not compare, you might have done mistake while looking for x1, y1, and like that. So that's just how it works. That is for matrix A. Now, how are we going to look for the other matrix A prime? We want to look for the other matrix A prime, whereby we are not using the standard basis this time around. We are not using a given basis. We are given basis, the basis given to us there. Let me recall, we were given two bases there. We were given b prime to be equals to, now let me write it out. We have it as minus 1, 0, 2, right? We also have another, you can go and check the question again. I have 0, 1, 1. Then this I have 3 minus 1, 0. So this is the given basis, not the standard. We are not using E1, E2, E3. You are not using that 1, 0, 0, 0, 0, 1. That is just for the first one with respect to standard basis. But here we are given a particular basis. And the second one given to us is E prime. E prime now is just an image of, this is an image of F3. While this one is an image of F2. Now let's check. For this one we have minus 1, comma 1. And the second part we have 1, comma 0. So what do you notice? This is an image of F3, 1, 2, 3. This is 1, 2. Okay, so how will you now look for A prime? The same procedure. We want to look for an image of F3 directly towards an image of F2. And the definition is that you have a linear map X, Y, Z that is equivalent to this particular expression here, which says we have it as X plus Y plus Z. This is what we are given, right? Then we have Y plus Z. This in the bracket. So therefore, I want to look for an image of F3 against F2. So now we are using the basis given to us. What's the basis given to us here? See it here. So this one is B prime now. So this one will now be, if it is standard basis, we always call this one E1, E2, E3. But if it's now given basis, we always call it, if it's given basis, we always call it E1. But to make it different, since we are using prime, it will be E1 prime. This one will be E2 prime. And this one will be E3 prime. So that means in this case now, I should have written E1. But E1 is for standard basis. But for given basis, we always put a prime there. Okay? Now that means this second, you see, I'm using the same template, the same general formula I stated earlier. So this one will now be E2, which is for the given second basis here, prime Abi. Then the third one now will be E3 prime. Now what will this one give us? Based on this definition here, okay, before I even write the definition, I know what to do. I'll have to bring in my E1 prime. My E1 prime is this first one. Okay, is this first one. I have it as minus 1, 0, and 2. Right? The given basis, right? I'm still on this one. Okay, this is what I have here. Okay, why am I using this? I'm using this F3. This image as F3. F3 against F2. Look at, can I check the question again? You have to follow respectively. Find the other matrix of phi with respect to the basis given this. F3 of F3 to F2 respectively. So that means I'm using this one against this based on the definition given to me. This one has three image, this one has two image. Okay, so please take note. Sometimes you can actually have another question that will come like this: x, y. Then you now have this one as x plus y plus z, y plus z. You can also have another one, 2z plus y. So making, so what image is this? This is image of f2 against f3. So that means this one will have been changed to f2 against f3. So you can come across questions like that. So it's not about cramming. I just want you to understand this clearly so that if the question is being changed in the exam, you can easily find a way to play around it. It's not by just knowing how this one is being solved. And by the time I now change the question entirely, you not really understand how to go about it. So please take note. Now the next thing for us to do, let's check. What's my E2 prime? Is this second digit? Zero. I'm sorry, I'm not taking my pen. I have this as 0, comma 1, comma 1. And what is the third one? That's 3, comma minus 1, comma 0. So I think that's what we have in that case. So when you get to this point now, you now use this definition. This is x plus y plus z. So now let's check what this is going to give us. What's x plus y plus z? My x, this is a linear mapping. X is minus 1, y is 0, z is 2. So on your calculator, you can just press your x plus y on your calculator. You press alphabet x, alphabet y. Then to use z, there is no z on that calculator. Just use m. So that means you are pressing alphabet x, alphabet y, and alphabet m. You now press the calc button. So when you press the calc button, automatically it will ask for what is x. So just put minus 1 and press equal to. So when you press equal to, it will ask for y. When it asks for y, put 0. Press equal to again. It will now ask for z. When it asks for z, put 2. So then press equal to again to give you the final result. So if I want to do that, um, if I want to try to do that manually, so that would be, if I'm not doing it computationally, if I want to do it manually, that would be, okay, x is minus 1, that would be minus 1 plus 0, z is 2. Minus 1 plus 0 plus 2, that would be 1 in that case, comma. Here is y plus z. Y is 0, z is 2. So that's 0 plus 2, that is 2. So that aside. So now let's try this one too. X is 0, y is 1, z is 1. So that's 0 plus 1, that is 2. Okay, this one is 1 plus 1, that is also 2 as well. So are you flowing? So that's how it works. One of the third one, x is 3, y is minus 1, and z is 0. So let's add. Sorry, x is 3, y is minus 1, and z is 0. So let's substitute here. What are we going to have? We will get 3 minus 1, that is 2. 2 plus 0, that's also 2 as well. So that's how it works. And then for this one, minus 1 plus 0, that is minus 1. Now, when you get to this point, you know the next thing to do. Next thing to do is actually when we have that x1, y1, x2, y2. So I have x1 of the second basis. This is f1. The second basis given to us. So this is the second basis given to us. This is an image of f3. Everything here is an image of f3. Okay. Now, what's now the image of f2? So that's what we want to do here. So the image of f2 is coming from this given basis here, whereby we have this image of f2. See it in here. This minus 1, 1, 1, 0. So this one will be, you put the minus 1, 1 here, then plus y1 also, then the second one will be 1, comma 0. So this one is E1, E2, E3. That's a prime for a given basis. But if it's not a given basis, you just use E1. So this one too will now be F1 prime, F2 prime. So I'm supposed to write out, but there's no space. So I should have written it out first. Like, okay, F1 prime plus Y1 F2 prime. Before I now write equal to, do you understand? But there's no enough space here. So I have to just manage this space I have here. So I said this thing is always constant on true towards this column. So I'll repeat it here also. And I'll repeat it here also. This one I'll repeat it. This one I'll always also repeat it here. So then this one will now be x2, x3 plus y2, y3. So now how can you solve this? So we need to solve this question here. That is, we need to solve this now from here. You relate this and this together. So how are you going to do that? So that means I have to manage this space here. So that means what I have to do from here now is I have x1. I said this first one multiply this first one equals to this first one. This is the same thing. So that means I will have x1 times minus 1. That is minus x. 1, abi. Then y1 times 1, that's plus this plus y times 1, y1 times 1 is y1 is equals to this one. Okay. Second equation is x1 times the second one, that's x1. Then y1 times 0, that's plus 0, is equals to this second result. Abi. This multiply second one, this multiply second one equals to this second digit. So trivially, I think you don't need to stress yourself. So x1 is 2. Automatically, x1 is 2. Abi now. Since my x1 is 2, what will my y1 be? So my y1 now will be minus 2 plus y1 is equals to 1. So y1 now will be equals to 1 plus 2, and that is 3. So automatically speaking, I already have my result for x1. My x1 is 2, my y1 is 3 in that case. So it's not something that is really hard like that. So I'll just come here. Okay, is there any space here? My x1 here is 2. Okay, my y1 is 3. Then I will stop that way. So let's quickly look for. Now I want to. This result here is for my A transpose. So hope you know. Any matrix I want to put here now should be my A transpose. That is x1 is 2, y1 is 3. I don't want to write, there's no space. I should have written it out again. I want to write 2 open brackets minus 1, but I'm just trying to skip step. A transpose, this is just what you need for A transpose. So let's just use eyes to balance it that way. So now the next one is this second row now. Let's do the second part. That's x2 times minus 1, that's x minus x2. Y2 times 1, that's plus y2 equals to this 2, right? So if I, okay, and second equation is x2 equals to x2 times 1, that's x2, y2 times 0, that's 0, equals to the second equation 2. Same thing, my x2 is 2. If my x2 is 2, substitute here, that's minus 2 plus y2 equals to 2. If minus 2 goes like this, that becomes y2 equals to 2 plus 2. And that means y2 is equals to 4. So y2 is 4. That means my x2 is 2, my y2 is 4 in that case. So I will have my x2 is 2, my y2 is 4. This are you flowing? That's how it works. Now this one now, x3. Similarly, I'll do the same thing for x3 too. Don't mind my rough work. I'm just trying to, since I've already done something similar from here, I showed you working clearly here. So I'm doing the same thing here also. You can do that too. X3 times minus 1 is minus x3, y3 times 1 plus y3. So I'm using this to multiply the first one equals to this first digit. So same thing, x3 times 1 is x3, y3 times 0 is 0, equals to this second part minus 1. So it's trivially, my x3 is already equals to minus 1. So if my x3 is equals to minus 1, I'll just come here and substitute it. Minus x3, that's minus times minus 1, that is plus 1, then plus y3 is equals to 2. So if this plus 1 goes like this, that means my y3 now is equals to what? 2 minus 1, and that's 1. So my x3 is minus 1, my y3 is 1 in that case. So do you start that logic? So that's how it works. So that's how it works for that. So I need to write it out. Okay. That means here in this case now, I'll have this one as my x3 is minus 1, my y3 is 1. Right? So if this is my A transpose, so what's going to be my A? My matrix A is now the transpose of the A transpose. So don't mind me, let me just put it somewhere here. My A now is equals to the transpose of the A transpose. So that means I'll turn all this vertical here to horizontal, all this column. This first column become my first row, and this second column become my second row. So this is my matrix for, I think this is not A. This is A prime that I'm looking for. That other hair, what I have here now, the question says find A prime. So I should have used another letter, or maybe I should just use letter D so that you not get confused. You can say find matrix D of this. This is why I don't want to use find matrix B. If I use find matrix B, automatically B prime is for given basis, and ordinary B is for standard basis. So it not really makes sense if you use matrix B. I can only use that matrix B if eventually I want to, maybe in my own mind I know that, okay, I know the matrix I'm looking for, but that B, already know in your mind that B does not represent standard basis. You should know that it does not represent standard basis, so you need to be very very smart about that. So I think that is fine. That is fine. So we are almost done with that. We are even done. I think I've answered the question. So the other matrix A prime that has to look for is this 2, 2, minus 1, 3, 4, 1. So please take note. Now recall, okay, my A prime now is 2, 2, minus 1, 0, sorry, 3, 4, 1. Yes, let me check again. That's what we have. Please take note too. X1 I have it as 2, Y1 is 3, X2, like that. So I have that result. So this is my final result. This is my final answer. Let's check the question. So I believe you have answered the question now. Let's check. Find A. This is our A. And I already showed the workings through the steps of finding the linear map with respect to standard basis. And I've also find the matrix A prime. I've done that with respect to this basis also. Use standard logic with respect to this basis. So I think that is fine in that case. So I remember that I said there's a last question. What was that last question? You had to note that last question also has its own proof. There's a proof for it. Let's say we want to look for the last question. I. Question I. How does it comes? So that question will ask you to verify or prove. Okay. So verify that, or they say prove that that second matrix that you actually solved for in that question I. This second matrix show that this question here is, if this answer you got is actually equivalent to, there is always an invertible matrix. We always have an invertible matrix P and Q, an invertible matrix called vertible matrix P and Q. And how we look for this invertible matrix, I will explain. Like there is a particular proposition for it. There is a proposition that states what P is and what Q is. But just know that there always exists an invertible matrix P and Q, such that we can actually verify that the second matrix that we just got here is equivalent to, when you multiply, when you take the transpose when you take the transpose of this first invertible matrix times matrix A. Remember that we got matrix A initially, then times matrix Q, where P and Q are invertible matrix. So what is our P? Now if I want to verify this now, I already know this one. I don't have any issue. And if I've done any mistake, I will know from here. Because if I solve this right hand side and it's not equal to this result, that means this answer is wrong. That means I've done mistake somewhere. So don't worry, you see that we usually get the same answer. I have P transpose A and Q. What's my matrix A? I already have it. But I don't know P, I don't know Q. So now what is P? I can actually represent P to be I can easily tell you that, okay, let me use my P as a linear map that is going to, okay, this P now is always it always map a standard base. It moves from a standard base. This standard base is E. We always map our standard base directly to what? To our given base, E1. E1. While this Q now, we always take a map of the second, okay, let me say, the given base, we always map to the standard base. Yeah, this is how it works. This is the two definition. Okay, I repeat. Do you know? I don't want to get this thing confused. I said we have what we call standard basis. We have what we call standard basis, right? Standard basis. This standard basis, I said um we always use these two things to represent that. Let's say we have okay, the standard basis of E now will be equals to the small e1, e2, e3, and that is a 3 by 3 matrix. 1, 1, 1. If it's a 3 by 3 matrix, you have this, right? Whereby this one is your E1, this one is your E2, while this one is your E3. We also have another standard basis, capital letter B, that we always have as F1, F2. That is for if this thing is image of F3 against F2. That's how you represent it. Not that we're not going to use F1 to F3. When I already know that the definition is coming from F3 to F2. So you have to consider what you have. So E first, then I think B used to take the highest part. Well, let's just leave it this way. So this is 2 by 2 matrix 0, 0, whereby this is our F1, this is our F2. I think this is what we have been using since. Okay, now let me clean that. That's for standard basis. That's for idea of standard basis. So how we get P and Q in this case? That's our main concern. To get P and Q now, please listen to this explanation clearly. Listen to this explanation clearly. Now let me take my pen back. Now to look for our matrix P and then take the transpose, what we are going to do is we will always relate this our standard base to our given base E prime. I think I already know what my E prime is and I know what my P prime is. It was given. In fact, we don't even have any issue. It has been given in the question. What if we were initially go and check that it is given. My E prime has already been given as the one with image F2, the 2 by 2 dimensional vector space. So it has been given. So you know what to do from here. This is for E prime, this is for P prime. So I think equivalently, what will be my B here? B will be my standard base. EB prime is the given base, my ordinary B is the standard base. And since this is having an image of F3, my standard base will now have E1, E2, E3. Sorry, don't let me put it that way. My standard basis we have it in this form E1, E2, E3, just like how we have it here. This one is E1 prime, E2 prime, E3. I don't know whether you understand that logic. So please take note. This is very, very common. Just pay full attention. You can watch this video, watch it like 3 times so that you get my explanation clearly. Okay. So now you have this. The second part here also, this one will be capital E of minus 1, 1. So that's what I want to come and write out here. First thing is to write out this proposition. You propose that P is of this nature, Q is of this nature. Propose it out first. So I think I don't have enough space for that. Let me quickly remove that box. Okay. Now, what is my E? That's my concern. Let me just put it somewhere here. Okay, I want to manage this space now. So what is this my E? Okay, sorry, I was given E. Let's start with, okay, I was given E prime. E prime is given to me as what? If you remember, E prime is given to us as, okay, let's check. Let's check it together. 1, 1 or so. Is it not 1, 1? Minus 1, 1, 1, 0. That's my E prime. Minus 1, 1, 0, 1 or so, right? Minus 1, 1, 1, 0. That's what we're given. And my B prime is given to us as what? Okay, you know what? Don't let me just, I don't want to bring this in yet. Let's do this. Let's find P first. Let's find P. And I still need to manage the space. I have my P, which is defined by a map of E to E prime. That's what we have as our E. So what's my E now? This E we actually have here, looking at it, is the standard base. E prime is the given base. And the given base here is this and this. And that's an image of F2. Automatically speaking, my E will now be equals to, since is an F2, that means I'll have a 2 by 2 dimensional space, matrix rather. A 2 by 2 dimensional matrix in this case, since it's having F2. So where this one will be my what? Small letter F1, small letter F2. So I'll just come here and say, okay, for this E that I have here, for this E that I actually have here, what would that give us? For this E that I actually have here, that will give us, you see, I'm not using, and take note though, this thing is not defined by phi. It's not a, so I'm not considering x comma y. I'm not considering phi of x comma y comma z. I'm not. I'm only using a linear mapping, a new one entirely. Just like a constant one that is, you know, like just like, okay, I'm only considering, I want to get matrix P, and this is just what I have. So I'm using it directly without considering this uh, linear map definition that is being given to me as x plus y plus z comma y plus z. I don't need that. So what's my E now? My E straight up just come here, okay, 1, 0, 0, 1 in that case, right? So that means in that case I'll just write, okay, open the 0, 1 comma 0, then 0 comma 1 straight up from E to E prime. So I'll just write put equal to here. So what's my E prime? My E prime now will not be of this format. Okay, I need my x, then my E prime. See, I'll take this one minus 1 comma 1. You know the way we used to do it now. Then you put y again, repeat the second one, 1 comma 0. You call this one your y x1, you call this one your y1. So you do the same thing, x2. This one will always remain the same all through. Okay, so that's just the logic. Please take note of this. Now let's solve this matrix. This is x1 times minus 1, that's minus x1, then plus y1 times 1, that's y1, is equals to 1. And also I have x1 times 1, x1, then y1 times 0, that's plus 0, is equals to 0 at the end of the day. So looking at this, x1 is 0. If x1 is 0, my y1 is 1. Okay, so please permit me to write it out. My x1 is, in this case now, my x1 is 0. Okay, my x1 is 0. My y1 is what? Is 1. So I've done that. So I need to solve for the second equation that is there. So how will I do this second part? I have minus x2, then plus y2 equals to this 0. Then I have x2 times 1 is x2 plus 0 is equals to 1. So my x2 is 1 here. If my x2 is 1, if my x2 is 1, my y2 is also 1. Yes. My y2 is also, I have 1, 1 in this case. Right? So now if I have something of this nature now, do you know that if I just taking this 0, 1, 1, 1 directly is my pt. So I don't need just ordinary. I didn't the formula is p now. Then I'll now have to take the transpose of this one again. So that means this is what I have here is my pt. Just like how we have this as at. Okay, what we have directly from here is your transpose. Okay, so what I've done here too, what I have here exactly is my p that I'm looking for, p transpose that I'm looking for. So my pt is already equals to 0, 1, 1. So I need to find q also. Similarly, let's find q. I have to manage this space. Okay, now let's find q. This is where we have q, our q now. So this b prime now is defined by what? No, now we are using b prime first. The given base is coming first. What's my given basis? You can actually go and check that again. My given basis, I don't know that is going to size this space, but I'll write it out again. My given basis, let's check it together from here. This is my given basis. Minus 102. Do you see that? Minus 102, 001. Minus 102, 001. And then the last one is given to us as 3 minus 10. Okay, then you close it. So that means in this case now, I think I have enough space that I have to come here. This b prime now is actually just direct. We don't need to start doing phi of no and this q. So you are using this one direct, just this directly. Okay, so my b prime now, according to this definition of looking for invertible matrix q, I'll just go ahead and okay, let me start. My b prime, I have this first result minus 102. Okay, minus 1 0 minus 102, and I also have what? 001, and the last one I have 3 minus 10. Do you agree with that? So equal to. So this is how it works. Now that I have this, the next thing for us to do from here, as usual now, you take your x, then what's your b? B is the standard basis. Standard basis of what? This is an image of F3. That's 3 by 3 matrix. Okay, so this one will be my E1, my E2, my E3. So that's what I'm going to put here. E1 here is 1 0 0. Okay, 1 0 0, and that's not all. My Y of E2, E2 is 0 1 0, and that's not all. I still have E3, so you bring in Z again of what? 0 0 1. So then this one will be your X1, Y1, Z1 to expatiate it from what we have here. Okay, this one remain the same all through, like I used to say, plus Y2 0 1 0, Z2 0 0 1. So Y3 0 1 0, and I have enough space again. So this one really take us time to solve. So now I don't know whether you can actually get our answer from me. I have x1 plus 0 plus 0. That means my x1 is equals to minus 1 straight up without stress at all. X1 times 1 is x1. X1 plus y1 plus z1. That's how it's going to work in that case. So I think, well, if my x1 is minus 1, what would be my y1? For the second part, 0, y1, 0. That's y1 is equals to 0, and trivially z1 is equals to 2. So we don't have any issue with this. We don't have any issue with this. It works straight up without any stress. It works straight up without any stress. So I think my x1 should be okay, should be minus 1. Or can I just form that matrix directly? If I can actually, yes, let me manage. I have to clean this since we've understood what we need from here. So guys, I believe you actually understand the concept I'm trying to pass across. Now let's check it again. I said looking at this x1 plus 0 equals to minus. So I just notice that this one is actually direct. Let me just open the matrix. My x1 is already minus 1 straight up. Then if I want to look for y1, that's this second one, this first one, this x1 multiply the second one, y1 then plus z, that's y1 is equals to 0. My z1 too equals to 2 directly. So here in this case, I notice that this one, x1 is equals to 0, y2, sorry, x2 is equals to 0, y2 will also be equals to 0. So I notice that I actually have the same result back. Since I'm going to have the same result, I'm going to have the same result back. This one is 1. So looking at this one again, I will have the same result back. This is 3, this is minus 1, and this is 0. Okay? So if I have something like this now, this answer here is my Q transpose. What I have initially is my Q transpose. But in the formula here, what I want to prove, I need just Q. That means Q now will now be take the transpose of Q transpose. So that will be this column become horizontal minus 1 0 3. This second column become the second row, and this third column becomes the third row. So this is my Q. Now guys, I have my PT. Where's my PT? 0 1 1 1. I have my Q as this, and I have my A. So now let's multiply everything and confirm whether we get this answer back. So that's the final thing to do from here. So now let's check. My matrix A, recall that my matrix A is 1 1 1 0 1 1. I'll show you again. My PT, I have it as what? 0 1 1 1 0 1 1 1. And I have my matrix Q just now as the one I just got now is minus 1 0 3 0 1 1 2 1 1. So this matrix A, you know where I got it from the beginning. Is that I use this short method, or you solve it out and then you have this result. Where is it? And then you have the same result. Now, what did that ask us to verify? That was to verify that this second answer, this final result, this answer we got for II is equivalent to this. So let's check. My second result is equivalent to the P transpose times the matrix A times Q. You know in matrix, I can't do the vice versa. So you have to follow it. My PT is 0 1 1 1, then times 1 1 1 0 1 1, then times minus 1 0 3 0 1 1 2 1 1. So let's multiply these two first. If this multiply this, I have 0 times 1, that is 0, plus 1 times 0, that's 0 plus 1, I have it as 1. So this will also multiply this one again. 0 times 1 is 0, 1 times 1 is 1. 0, this one multiply, 0 times 1 is 1 plus, I still have 1. So this multiply this again. 1 times 1 is 1, plus 1 times 0 is 0. So if I add it together, I have 1. If this multiply this, I have 1 times 1 as 1 plus 1 times 1, 1. So 1 plus 1, that is 2. So this multiply this again, I also have 2. Similarly, 1 times 1 is 1 plus 1 times 1 is 1. So if I add it together, that's 2. I believe you know how to multiply matrix now. It's not something that is really hard. So let's do the final multiplication here. But take note, oh, do you know that what we want to prove now, we must get this A prime back. And what's our A prime? Let me write it out. 2 2 minus 1, 2 2 minus 1, 3 what? 3 4 1. So that's what we must get. If we not get it, that means this solution I got here is wrong, totally wrong. So now let's confirm. Let's confirm. Let's confirm. So if this multiply this, if this first two multiply this first column, I have minus 1 times 1, that is minus 1, plus 1 times 0, 0, plus 1 times 2, 1 times 2, 2. And I stop. So let's do the same thing. This and this second column. So 1 times 0, 0, plus 1 times 1, 1, plus 1 times 1, 1. So I've done this first row and second column. Done. I have 1 here, I have 1 here. So let's do the last part. First row and last column. So 1 times 3 is 3. 1 times 1, that's 1. 1 times 1, that's 1. Then I stop. Right? Now let's check again. What of this? Okay, let's check this out. I have 1 times minus 1, that is minus 1. Then 2 times 0, then 2 times 0, that's 0, plus 2 times 2, that's 4. So looking at this, it seems I'm not getting the same result. But let's shoot. We still have, we know what to do from there. So I have 1 times 3, 3. 2 times 1, that's 2. 2 times 1, that's 2. And then the last part, if this multiply this, I have 3 plus 2 plus 2. Now let's verify. Let's try to check. Let's try to check this out. Whether it is right. So I notice if I have 0, 1, 1 times this 1, 1, 1, 0, 1, then okay, if I did the multiplication, you can also try to, do you know, I can also use calculator for this. You can use calculator. Call this one matrix A, B, and C. I didn't think I can display my calculator now. I'll just go ahead and run the matrix and I'll multiply the three of them. But looking at this now, if I multiply it, I notice that this first result is not this. Trivially, it is not. It is not. But let's check. Minus 1 plus 2, that is 1. I have 1 here. Here in this case now I have 2. In this case I have 3 plus 1 is even, I'm even seeing another value entirely, 5. This one now, I have minus 1 plus 0, this is 3. Well, this is 3 plus 2 plus 2. And this gives us 7. Well, this gives us 7 as well, which is still not equivalent. Is still not equivalent to our to what we have as our A prime. So I just want to confirm whether there is no any error here, because I've done this and I notice if I multiply it, I should still have the same result. I still have the same result. Okay, you know what? Maybe if you try another question, I think it should work for another type of question. There's a particular question that because looking at this, I look at this now, we still have, after the multiplication, it looks, we have 2 by 3 images, 2 by 3 images, which is still in line with each other. So that means for this last question now, we are still having issue with this. Okay, verify that this is equals to this. And looking at it now, we have it not to be equal. That means there is something wrong somewhere. And what I noticed here is that do you know there's a proof for this? I think it was given to you guys as an assignment to show the proof. I think I actually have the proof here. I still state the proof. What I'll just do is to, I can display it. Let me check whether I can add image. Oh, so I can add image, no problem. That's nice. So I feel like okay, maybe in the next video I'll try to put a correction to that, and I will also make sure that I show the proof for this. And that will be the best thing I would, that is going to be the next thing I will do for the next video explanation. That will be for video series. That should be video series 3, if I'm not mistaken. That should be video series 3. So for the next question we are going to try. I think I have a question here. There's a question here that we need to try. Come, let me open a fresh page. This question here is not something that is really hard like that. It's direct. So all you just need to do is to follow the same steps that we just used. Just need to follow the same step that we just used. And from there, you can easily know what to do from there. So, and the funnest thing, this particular solution here is what we have in the material for material 2. So that means, and that is the same solution that is being used. So that means there's something wrong somewhere. Because if I display I can still display don't worry, next video I will display the solution. The main material, the solution that is there. We are correct. A is correct. We got our P as what is in the material. Our Q2 is also the same thing. But the issue now, A is also the same thing. We got these 3 results. But the issue now is that If you multiply these three things together, the result is not equals to this. And I noticed that in that material now, we have our own answer. After multiplying, this is our result now. But in the material, after they multiply this, and this, they say it is equivalent to E prime directly without even showing any workings. 341. And even though if I try to multiply this clearly, I'm very sure it is not equals to this. But let me even confirm again. If I multiply this and this, okay, yes, there's an error in our multiplication. Let's correct that. I've seen that. 0 times 1 is 0. 1 times 0 is also 0. I think that is where we make our mistake from. So, guys, so let's correct that. I was like, what was wrong? What was going on? Okay, so now let's check it. Let's quickly correct that. Sorry for the delay in that case. Let's multiply it again. If this 0 multiply 1, 0 plus 0, I have 0. If this multiply this, I have 0 plus 1, I have 1. This multiply this, I have 0, I have 1. This and this, I have 1 plus 0, 1. If I'm okay, this and this, I have 2, right? This and this, I have 2. Now let's do the final multiplication with this. Let's confirm. I hope we get the correct answer because I was like, what's going on? So now let's multiply this again. 0, 0, 0, 0, I have 2, right? I have 2 there. If this multiply this one, I have 0, 1, 1, and that is 2. 1 plus 1, that's 2. If I multiply this and this, 0 times 3 is 3, 1 times 1 is 1, 1 times 1 is 1. If I'm not mistaken, let's check. This is minus 1. Is this 1 or minus 1? This is minus 1, so you need to be very, very careful. This is minus 1. So let's multiply again. This is minus 1. Let's multiply again. 0 times 3 is 3. 1 times minus 1 is minus 1. 1 times 1. I hope there's no any issue with this. Is this 1 or minus? I think it's 1 now. It's 1. This is 1. This is 1. I think this is correct now. This is correct. Wait, let's check this down part because I noticed this last one is not looking like minus 1. We now have it as minus 1. But let's check this one. If this multiply this. In fact, I'm not supposed to even stress myself. I'm supposed to use calculator for this. I'll try it on my calculator now and then give the final results. Then you can do the multiplication later. If this multiply this one, I have minus 1, 0, minus 1, 0, and 4. And 4 minus 1, that's 3. Done. This and this. 0, 2 times 1 is 2, 2 times 1 is 2, that's 4. I think we have issue with this last part. Let's check. I hope you get 1 for this. 3 times 1 is 3. 2 times minus 1, let's say is minus 2. 2 times 1 is 2. 1 plus 2, that's 3. It's not even working. There's issue with this last part too again. Or is it that there is an issue with this last multiplication, this and this? 1 times 1 is 1, and then 1 times 1 is 1. If I add it, that's 2. So there's an issue with this last 2 now. That's only the question. That's only the thing. So what I'll just do now, let me quickly use my calculator to do that, to verify the main correct answer. So I need to be very, very sure. Because in this material, they said, directly in the material, they say if I multiply this 3, I'll have this matrix back. But they did not show the workings. And I've already come down to solve the multiplication and it's not really working. So let me quickly use calculator for that. I have matrix. Let me pick the dimension. Matrix A. Matrix A is 2 by 2. So I have it as 0, 1, 1, 1. So I've done that on calculator. So let me input for matrix, the second matrix there. And that is, let me just call it matrix B. And that is 2 by 3 matrix. And that is 1, 1, 1, 0, 1, 1. So I should have reviewed this before making this video. That's why we are going through all the stress. Because I believe we should be able to get the final answer directly. So now let me put the last matrix, which is 3 by 3. And the 3 by 3 is minus 1, 0, 3, 0, 1, 1, 0, 1, 1, 2, 1, 1. So I still want to verify this minus 1. Let's check again. Is it minus 1 also? Or this particular digit? I want to confirm that is minus 1. Let's check. This was our Q, right? Q transpose. We have it as 3 minus 1, 0, right? 3 minus 1, 0. So this turns to vertical, this turns to vertical, this turns. So it's minus 1. So in the material self, they made a mistake. This was one. The material, check it. You can, if you have the material, you can check it out. Let me check it again. It was one. If it's a typographical error, the year I noticed here they use -103 correct, 011 correct, 210, and this is meant to be -1. This is supposed to be -1. Okay, there's a very big mistake here. So I've input all this in the on the calculator now. Let me multiply it together and then give the final results straight up. I have this as -1. I have to correct the -1 part, so I've done that. So now let me multiply matrix A times matrix B times matrix C. So calculator gave us 23240 and I think that's what we are supposed to get. Because if I multiply this and this now, this is 2 times 3, 2 times -1, that's -2, then 2 times 1 is 2. If I add all this one together now, that's -1, okay, that's -1 plus 2. This is meant to be 1. This is correct though. Maybe I made mistake while pressing this. This is plus 1. The only issue now is this guy that is here. Let's check again. This and this. This and this. 0, 1 times -1, that is -1. 1 times 1, that is plus 1. So I only have this part as 0. So this is the only issue we have now. So is there any error from what we did here? Is this one 0? How did it get this -1? Let's confirm. This -1, where is it? The -1 is actually at this top part, right? When you did the transpose at this point. If I multiply this, minus x3 plus y3 is equals to 2. This is it here. And I have my x3 is equals to -1. So my x3 is equals to -1. Put it here. -1, that's plus 1. If it goes like this, I have plus 1. And that is 3. Then this is meant to be 3. Wow. I have to fix this. I have to fix this. Let's check again. This is x3 here. Minus x3 plus y3, right? Equal to 2. This is it here. Use that logic. Then my second equation is x3 plus 0 equals to -1. Automatically speaking, let me also confirm this -1 from the beginning. Y plus z -1 plus 0 is correct. So now x3 is -1. If I now substitute -1 here, I have plus 1. I have plus 1, right? So plus 1 goes to I have 2 minus 1. That's 1. So that means x3 is -1, y3 is 1, which is correct. X3 is -1, y3 is 1. So when we take the transpose, we still have this result. So I think there's an issue somewhere while multiplying. I don't know why that is almost close, but not exact. And we should check the correct, we should get the same thing. In the material, they only assume that if you multiply it is equals to this directly without checking. Because if I check this again, this is 0 here. I'm supposed to have -1. Other this is correct, this is correct, but only this part. I still want to confirm again. 0, 1, 1. 0 times 3 is 0. 1 times -1 is -1. Then 1 times 1 is 1. So, then which makes it 0. I think there's an issue here. Don't worry, I'll try to make my research on that and confirm why it is not. Or probably if you try another question, then we can compare. I'm very, very sure that question might work. If I try another question, it will work. I don't know why this is giving us a just this point here. Okay, but please take note, this is how it works. This is the main step to follow. Because I've tried my possible best to break this explanation down to you clearly. So if you are seeing any other solution elsewhere, different kind of solution, I've been seeing different kind of solutions. So please follow the main steps. These are the steps. All these things, I follow the theorems. That's how it is being stated in the theorems. All this E1 that I'm writing, where is it? All this E1, E2, I actually make use of the theorem. Where is it? All this E1, E2, E3. That's the main theorem that we used to follow. So if you like, do it anyhow, then you get to understand. So please just follow these steps and then I believe you are good to go. So the only issue we have here is just this digit, and I already promised you that I'll fix it up. I'll look into it, then I'll get back. I'll get back to you guys. I'll surely make another video on that. So thanks for watching.